Hello, good evening. Am I audible?
Good evening, ma'am. Yes, you are.
Good evening, ma'am.
Good evening. Aniket, you forgot the Finkelstein reaction. Okay.
Ma'am, what happened?
You forgot Finkelstein reaction in Allen?
Finkelstein reaction in Allen, no? Oh, yeah. Wait, ma'am, how do you know?
I
Ma'am,
know.
wait, how do you know, ma'am?
No. How you can forget that reaction?
Ma'am, I mean, it like slipped through my mind.
Okay, so all of you have revised electrochem. Aniket and Vivan, I think Bhumika, you were also not there in the last class. So have you
Yeah,
seen
but
that
it kind of came for exam, so I'm fine with it.
video dekha or that
No,
one
I
recording?
saw the recording. I wrote the notes. I mean, I know the topics you taught, so.
Okay. What about Aniket and Vivan? I think you also know about
We
the
had exam
topic.
on this, yeah.
How was the exam for this one? I saw the paper. It was easy only, but
Ma'am, do you see JE or NEET?
neat.
Okay. No, it's fine, only on module questions.
Okay. And Vivan, for you, it's a J or neat only?
Oh, J.
J. Okay. How was that paper?
I didn't do good in it. I messed up with some.
Okay. And you saw the recording of last class?
No.
Ma'am, wait, ma'am, like, how do you know that I forgot Finkelstein reaction, though?
No, it. Someone told me.
Ma'am, was it Ananya?
Huh.
Arey, yaar.
Okay, so tell me if you have a doubt in that. I think in the last class we have done till standard hydrogen electrode, right?
Yes, ma'am.
Shivani, any doubt till there?
No, ma'am.
Pradhanya? Arjun?
No doubt.
Ma'am, till what did you do again?
We have done till standard hydrogen electrode. So we will just briefly discuss what we have done. Pradhanya, you tell me what is electrochemical cell?
Ma'am, it converts electrochemical cells, no? It converts chemical into electric power, right?
Yes, chemical into electrical energy. It is for which type of reaction? Spontaneous or non-spontaneous?
Spontaneous, and delta G is less than 0.
Delta G is negative, and in this, anode is negative or positive?
Anode negative, cathode is positive.
Yeah. Okay. Now, Arjun, you tell me what is the function of salt bridge in electrochemical cell?
Ma'am, it maintains neutrality. And
It maintains a neutral.
and it completes the circuit.
Yes. Aniket, you tell me if there is a, let us suppose, cell potential of 1.1 volt in a cell, and if I apply some external voltage in the opposite direction, like opposing voltage of magnitude greater than 1.1 volt, then what happens to the direction of current?
Go backwards, right?
Backward means which direction?
Ulta, right? So if it's going forward, it'll go backward, right?
Nee. Without that, without opposing voltage, what is the direction of the current in the cell? Galvanic cell mein.
From positive, negative, no?
Like anode to cathode or cathode to anode, like.
So from positive to negative, no? So it'll be from cathode to anode.
Or agar 1.1, you have to mention this thing. It moves from cathode to anode. And if the opposing voltage greater than 1.1,
Yeah, then anode to cathode.
if it is equal to 1.1,
then no movement, equilibrium.
no current flows through the circuit. Now, next question. After this, I'm writing one equation. You tell me how to represent the cell. If I am writing Mg,
Ma'am, did you do like effect of dilution, then Colak's law?
no, that we have not started yet. Just
Okay,
one.
ma'am, what about molar conductance and all?
No, conductance abhi start nahi kiya. We have just started with electrochemical cell. We will do Nernst
Ma'am,
equation.
because in Allen we started with molar conductance and all.
Was it
Started
Mg plus 2 or Mn plus?
Mg2 plus Fe. Do it in the cell representation one.
It's like Mg,
Hmm.
then single line,
Hmm.
Mg2 plus,
Hmm.
then it's the salt with like 2 lines,
Hmm.
Fe2 plus, then Fe.
Yeah, this is a solid representation. And if I am writing the equation Al plus Al to Al3 plus, Bhumika, you tell me if this is a cell representation, then how to write the complete reaction?
Al plus Fe2 plus gives Al3 plus Fe.
Sure, that will be the equation.
Balance करना है ना?
Is it correct?
I think we have to balance it.
कैसे करोगे?
I think it'll be 3 Fe2 plus.
इसको क्या करना है? First to write the half cell reactions. Anode का reaction, tell me which reaction will be at anode?
Al gives Al3 plus.
How many electrons?
3.
3. Cathode reaction is?
Fe2 plus to Fe.
2 electrons Fe. When we add both the equations, we have to make sure the number of electrons are same. So first equation should be multiplied by 2, second should be 3. So it should be 2Al plus 3 Fe2 plus gives 2Al3.
2Al3 plus 3 Fe.
So if cell representation is given, first to write the half cell reactions and then add it. Because in Nernst equation, today we will do, otherwise you will make mistakes in that. So always do in this way if cell representation is given. Now next thing we have discussed what is electrode potential. Shivani, you tell me what is electrode potential, what is reduction and oxidation potential, what is the relation between them?
Electrode potential. Electrode potential is the tendency of electrode to gain or lose electrons. Reduction is the tendency to undergo reduction or basically gain electrons. Oxidation is the tendency to lose electrons. And the relationship is reduction potential is equal to minus oxidation potential.
Yeah. Now Aditi, you tell me what is the difference, what is EMF and what is the difference between EMF and potential difference?
Ma'am, EMF is the potential difference between the electrodes when there's no current flowing. So it's maximum voltage, and potential difference is the potential difference between the electrodes when the current is flowing.
Now next point is, Aniket, you tell me on what factors the electrode potential value depends. What are the factors?
I didn't do the theory, I just did the numericals, but ma'am, will it be nature?
Nature of what?
Electrode.
Nature of metal. It
Yeah, so
depends
nature of the
on
electrode also.
nature of metal and its ion.
Then pressure, I think.
Not pressure, temperature.
No, temperature is also there. Pressure is also there.
And what is the next thing?
Ma'am, pressure is also there, right?
Pressure in terms of gaseous thing.
Yeah, and then there's like concentration also, right?
Yeah. Nature of the
and then number of electrons, I think.
only these factors: nature of the metal and its ion, concentration of the ions in the solution, temperature. Pressure in case of gaseous thing, but normally we are writing only temperature. Next is Pradhanya, you tell me what is standard which electrode is chosen as the reference electrode and what is the value of E naught for that?
Ma'am, standard choose hydrogen and E naught value is 0 for it.
0. Arjun, you tell me what is the formula for calculating the EMF of the cell?
Will it be reduction potential of cathode minus reduction potential of anode?
Yeah. Vivan, we have done electrochemical series also, na? What is electrochemical series that I have explained?
Yes, ma'am.
Okay. Vivan, what is electrochemical series?
I'm not sure, ma'am.
Sorry.
I'm not sure.
Aditi, you tell me what is electrochemical series?
Ma'am, all the elements are in order of decreasing reduction potential.
The arrangement of all the elements in the decreasing order of the reduction potential values, that is a electrochemical series. The element having more value of reduction potential, it undergoes reduction. The element having lesser value of reduction potential, it undergoes oxidation. And EMF value gives you the spontaneity of the reaction. If the EMF value is positive, reaction is spontaneous. If it is negative, reaction is non-spontaneous. So this is all we have done in the last class. Have we done that numerical also? Why copper sulfate is stored in zinc container or
No, ma'am.
no? Okay. Now I
Ma'am,
will
is it
give,
because it can displace?
but how will you prove it? I am giving you the numerical. All of you just solve it. The question is, can we store, like if this question comes for 2 marks, how will you write the answer? Can we store zinc sulfate solution in copper cylinder? It is given that E naught of zinc, E naught of zinc is minus 0.76 volt and E naught of copper is plus 0.34 volt. So how to solve this question? In 10th grade, you have done zinc is more, copper is less reactive than zinc, so it will not displace uh, zinc from its solution. But how will you do this? First, you write an equation. Okay, if copper reacts with zinc sulfate, if the reaction takes place, what would be the reaction? Then we will check whether that reaction is feasible or not. So if we store copper in zinc sulfate solution, if the reaction takes place, it will be copper sulfate and zinc. Now we have to check whether this reaction is feasible or not. If this reaction is feasible, we cannot store. If the reaction is not feasible, we can store it. Now in this case, EMF of the cell we can calculate, which is E naught of cathode minus E naught of anode. It is also called E naught cell. What is cathode here? Copper is oxidized to Cu2 plus, zinc 2 plus is reduced to zinc. So cathode is zinc here. It should be minus 0.76 minus copper is oxidized, so it is anode 0.34. So when you solve it, it comes out to be minus 1.1 volt.
Ma'am, did you give it as ulta? Is it Cu and Cu2 plus? No.
Cu converts into Cu2 plus.
Yeah, and then you wrote
That is-
Cu2 plus converts to Cu.
Here.
Yeah.
No, that is the reduction potential values. This data is for the reduction potential values. In reaction, one thing will oxidize, one thing will reduce. But when we are calculating EMF of the cell, we are substituting always the reduction potential values, not the oxidation potential. So data is reduction potential values of zinc and copper. You have to check which is oxidized and which is reduced from the reaction and substitute their values.
Okay.
See,
ma'am, sorry.
so this is reduction potential value. Equation, so you can see that zinc is reduced, copper is oxidized. So this is reduction potential of zinc minus reduction potential of copper. Because E naught cell is negative, so reaction is not feasible. If reaction is not feasible, it means it won't react, we can store. You have to show it like this. Logically, if it is a MCQ question or that, you can do it directly. But if it is a 2-marker question, you have to show with the steps. any one of you still have a confusion in the E naught values, how I have written and what is oxidation reduction, tell me, because it is very basic thing. If you are if you have a confusion in this, then you will make mistakes in Nernst equation also.
Ma'am, so like to take which one would be anode and cathode, did you just compare the values and see which one has a lower reduction?
Yes.
It'll be an okay.
देखो इसमें हमें रिएक्शन वी हैव टू चेक whether it is feasible or not. तो इस केस में we will see from the reaction के which is cathode and which is anode according to the reaction, and then we will substitute the values. But normally अगर E naught values are given, then you can check कि जिसका E naught value is more, that undergoes reduction, which is less, that undergoes oxidation. Kid got it?
Ma'am, wait,
Let-
can you repeat?
See, let us suppose I am giving you, leave this question, let us suppose I am giving you two values कि E naught एक metal का है 0.8 and E naught of second metal is this. I have written like this, right? Now first you should know कि whether I have written the reduction potential value or oxidation potential value.
Ma'am, both reduction you wrote, right?
Both reduction potential values. अगर मैं इन दोनों का cell, if I form the cell of silver and copper, which metal will reduce and which will oxidize? How will you come to know?
Oh yeah, that's my question only, right? Like in this equation, you've written both as like reducing. So like,
Wait, now I will explain. I think you have a confusion here. See, leave this question. If I am giving you this data and I will ask you which is cathode and which is anode. So you compare both values. It is reduction potential values. But if I form a cell, definitely one will reduce, the other will oxidize. So how will you know which will reduce and which will oxidize when you are forming the cell? Silver ka value is more. So it means it has more tendency to reduce. So when you're forming a cell between silver and copper, silver undergoes reduction, copper undergoes oxidation. But जो E naught values होती हैं, that is always they have given as a reduction potential values. जिसका reduction potential कम होगा, that will oxidize, another will reduce.
okay, that was my question. Yeah. So the higher SRP value, it'll be like cathode.
Will be cathode, yes.
Okay, fine, understood.
But is question में there was some like because we have to check whether this reaction is feasible or not. So reaction के according we have chosen कि which is cathode, which is anode. Negative आ गया तो it means reaction is not feasible.
Understood, ma'am. Fine.
Is clear to everyone this question?
Yes, ma'am.
Okay, now I am starting the next topic, and from that topic, it is 3-marker question. Always comes in board exam, and it is very important topic. The relation between the electrode potential and the concentration. Relation between cell potential. Cell potential means EMF. Cell potential and concentration. Till now, we have done the standard thing. Standard means when concentration is 1 molar, then we can find E naught cell is equal to E naught cathode minus E naught anode. But if concentrations are different, then how we can calculate the EMF of the cell? So there is one equation for that which is known as Nernst equation. Nernst equation, which gives the relation between EMF and the concentration. So there is no derivation in your syllabus. You have to directly learn the equation. E cell is equal to E naught cell minus 2.303 RT by NF log concentration of products by concentration of reactants. That is the equation which you have to learn. Because in this case, 2.303 is constant, R is gas constant, T is temperature, which is always 298 Kelvin we are taking in Nernst equation. F is Faraday's constant, its value is fixed, which is 96,500. We'll do next topic, coulombs. So these 4 things are constant. So we can put the values, and it is found that this value is 0.0591. N log square bracket means concentration of products by concentration of reactants. What is N here? N is number of electrons exchanged. Zinc is losing 2, copper is gaining 2, so N value is 2. How many electrons are exchanged during redox reaction? E naught cell, if they giving you directly substitute, otherwise you can calculate E naught cathode minus E naught of anode, reduction potential of cathode minus reduction potential of anode. And this point is very important. If you have any solid metal like copper, zinc, silver, anything is written, for pure solids and pure liquids, the concentration is always taken as 1. The concentration of pure solids and liquids is always taken as 1. So this is the Nernst equation. Note it down. Then we will practice 2-3 numericals.
And what have we written in the last line?
The concentration of solid metal. This is metal solid is equal to 1.
Understood.
Wait, ma'am, didn't you say that's of pure solid and liquid?
It's same thing. When it is written in bracket pure solid, or they will write in bracket pure liquid, then its concentration is always taken as 1. Liquids mainly they won't give you. They are giving only solid metals. I will give you an example, then it will be clear to you. Now the first question is, and write down one more thing for Nernst equation should always be in the reduction half cell. Equation should be in, always you have to write the reaction in the reduction half cell. I will tell you what does it mean. Our first question is, I will take one simple one. Write down if E naught value of copper, if E naught value of copper is 0.34 volt, is 0.34 volt, how will you calculate the EMF value? I will write in short, calculate the EMF value. And the solution is in contact with (0.1 molar in copper ion. Copper ions. The E naught of the cell is given. You have to find the EMF value when the solution is in contact with 0.1 molar copper ion. See how to solve this question. First thing, you write the equation. And it is the equation for only copper because there is a copper ions from which the copper is deposited. So copper ions ke liye equation you always write copper 2 plus ion. You always write the equation in the reduction half cell. Reduction half cell means it should be copper 2 plus 2 electrons gives copper. It should always be in the reduction half cell. That should be the equation. Note value is given. You have to find EMF of the cell. Concentration of copper ions are given. So we will use the Nernst equation. E is equal to naught minus 0.0591 by n log concentration of products by reactants.
Ma'am, but like, how do we know that it is if it is Q-pris or Q-prick?
It is Cu2 plus ions here.
Oh, okay,
Just
fine.
I missed that 2 plus, so it was Cu2 plus ions. So concentration of product here, product is Cu and reactant is Cu2 plus. Products by reactants, like this you have to write the first, always write the formula, then substitute the values. Because this thing I'm every numerical I'm telling you you have to first write the formula because that carries half mark. Then E naught value is 0.34 minus how many electrons are exchanged in this reaction? Should be 2. So N value is 2 log. Copper metal is a pure solid, it is 1. Concentration of copper ions are given as 0.1. What should be the value comes here? 0.34 minus 0.0295 log 10. Log 10 value is 1. So you have to just subtract it. You will get the value of this one. It comes out to be 0.31 volt. Units of electrode potential is volt. So like this you have to, all these numericals are very simple. See, you have to just substitute the values.
Mom, are we taking Cu1 because it's pure?
Agar only metal is written, so its concentration always you have to take it as 1 because it is pure
Yes.
solid.
Okay.
All of you write down this one, then I'm giving you similar type of 2 numericals. Log values, they will give you an exam, but log 10 raised to the power thing you should know. Okay, log 10 is, log 1 is 0 and log 10 raised to the power n. If it is 100,000, then it is n.
Ma'am, they don't give the values of log.
In exam, they give you.
Ma'am,
Board
in my
exam,
paper they didn't give.
which log value you needed in
Those
the
log
paper?
2, ma'am.
हाँ, log 2 भी learn करना है. Log 2, mainly they give you in board exams, but log 2 you just learn it because in kinetics, in one derivation, this value you need. 0.3010.
Ma'am, will they give 0.1, 0.1?
Sorry?
Like log 0.1, 0.2?
No. They all will give you this value. No need to remember any other value of log. Log 10 raised to the power n is n and log 2 is this one. That's it. I'm giving you one question. All of you do that. Calculate the potential of hydrogen electrode. Calculate the potential of hydrogen electrode in contact with a solution. In contact with a solution. pH is 10. Next is I'm giving you 3 questions. All of you just do that. Zinc rod is dipped in 0.1 molar zinc sulfate solution. Salt is 95% dissociated. Calculate the electrode potential and it is given E naught of zinc is minus 0.76 volt. Now third one, Al to Al3 plus 0.01 molar, nickel 2 plus 0.001 molar to nickel. Calculate EMF. E naught of aluminium is minute, I will check the value. Minus 2.36 and E naught of nickel is minus 0.25. All of you do these three numericals. And for the third numerical, you have to first write the half cell equations, then you write the complete equation. Bhumika, will you try the first one? How to start? Just tell me how to start it.
Mom, the second one is 0.76, right?
Minus 0.76. Yeah, everyone.
Getting like the log like log 1 by 0.095. So what should I do?
Isko just simplify it. It becomes 1000. Okay, here I will give you one log value, then try to simplify. Log 95 is 1.977.
Okay.
Bhumika, you're done with the first one?
No, I started with the second one first.
Who all have done with the first one?
I did it now.
What is the answer?
Minus 0.591.
Okay, and Vivan, your answer?
Same.
Okay, first one, Aditi, you have done?
I'm not too sure about it.
Okay, first one, I will explain. All of you listen carefully. Calculate, it's very important numerical. Calculate the potential of hydrogen electrode in contact with a solution whose pH is 10. So what is given in the question? pH of the solution. pH is 10. What is the formula for pH? pH is negative logarithm of H plus ions. That is the formula of pH. From this pH, you find the concentration of H plus ions. So log of H plus becomes minus 10. So H plus concentration becomes antilog of minus 10, which is antilog is 10 raised to the power that number. And 10 raised to the power minus 10. Antilog of some number is 10 raised to the power that number. So this is the concentration of H plus ions. Now this is hydrogen electrode. I have told you always have to write the equation in the reduction half cell. So it should be H plus electron gives you H2. You can write, because either you can write half H2 or you can write 2H plus 2 electron gives H2. Either thing is fine. This is the equation for the hydrogen electrode. So E is equal to, we use the Nernst equation, E naught cell minus 0.0591 by N log. Product is H2, hydrogen gas concentration we will take. If there is any coefficient, it becomes the power in the concentration term. If there is any coefficient in the equation, it becomes the power in the concentration term by H plus. What is the value of E naught for hydrogen electrode? Pradhanya, tell me. E naught value for hydrogen electrode is?
Mom, it will be 0.
0. What is N value here in this question?
Mom, will be 1.
Because one electron is exchanged, so it is 1. Log hydrogen gas is 1. Gas ka pressure is 1. Hydrogen gas pressure is 1 atm. And H plus concentration we just found 10 raised to power minus 10. Now we have to just solve it. It becomes minus 0.0591 log. When you take it in the numerator, it becomes 10 raised to the power 10. And log 10 raised to the power n is n. So which is minus 0.0591 to 10, which is minus 0.591. So like this you have to solve. So pH से you find H plus ion का concentration. Then using Nernst equation for hydrogen electrode, you find the E cell. Aniket and Vivan, you have done in the same way.
Yeah, ma'am. Same way as well. Ma'am, but like, what's the value of log 0.095?
Log 95 is 1.977. Now you have to simplify.
I'm done with second one. Don't do.
You are done with second. What is the answer?
Minus 0.7.
Second में?
Yes, ma'am.
Second should come out to be positive number.
No, even I'm getting negative.
For second one, I will check.
Ah.
1 minute. Okay, yeah. What is the answer? Minus
799.
Correct है. Bhumika, same answer you got?
Yeah. I think I made a calculation or sign mistake somewhere.
What equation you have written for the second one?
What?
Equation. What is the equation for the second question?
Zn plus nahi. Zn gives Zn minus plus 2a.
And this one, Zn gives Zn 2 plus 2.
2 plus
Like
plus
this?
2.
Okay. Shivani, you have written the same equation for the second one?
Ma'am, I just started. I was doing the first one right now.
Okay. Just tell me whether this equation is correct or not. Read the second question and tell me whether this equation is correct or not.
Mom, technically it's wrong.
Why?
Mom, the arrow should be backward.
Bhumika, you always have to write the reduction half cell. इक्वेशन में हमेशा रिडक्शन हाफ सेल में लिखना है फॉर द नर्स्ट इक्वेशन. It should be like this.
Yes, ma'am.
Now in this question I will explain it. Zinc is dipped in 0.1. The concentration of the solution is 0.1 molar and the salt is 95% dissociated. So 95, how many zinc ions will be there? Out of 100, 95 zinc ions are there. Means 100 में से 95 is the zinc sulfate which is dissociated. So you are getting 95 ions. So 0.1 ka 95% dissociation means what should be the concentration for zinc ions? 95% of 0.1. 95 by 100 into 0.1. Because total concentration is 0.1. Out of that, 95% is dissociated. So how much will be the concentration for zinc ions? It is this much, which is 0.095. That is a zinc ion concentration. Now all of you solve it and tell me the final answer. Only this was the additional step. Instead of directly giving you the concentration of zinc ions, they have given 95% dissociation. Arjun, tell me the next step.
Oh, ma'am, we have to this thing formula.
Is equal to E naught minus
Ma'am, minus 0.0591
Hmm.
divided by n into log of
what is N here?
2.
2 log of product. What is the concentration of zinc?
Ma'am, 0.095.
That is zinc ions. Concentration of
1.
products 1. Zinc is a pure solid. It is 1 divided by 0.095. Yeah. So this, what is the E naught value? It is given in the question, minus 0.76. Minus 0.0. When you divide it by 2, you will get 295. Log 1 by 0.095 can be written as log 1000 by 95 and log m by n is known as log m minus log n. So minus 0.76.
Mom, you can just directly take the reciprocal, no? And then just
Reciprocal of that also you can do, but उसके लिए 95 का log is given, so again you have to take it in the terms of 10 raised to the power thing. You are saying we can change the sign and take it in the numerator,
yeah,
right?
Mom, it will be easier that way, no?
Then you will get 95 into 10 raised to the power minus 3. तो वो
No,
same ही आएगा.
okay, fine.
95 का value given है ना, then same thing you will get. Log 1000 is 10 raised to the power 3, so its value is 3. Log 95 is given as 1.977. So you will get minus 0.76 minus 0.0295. When you subtract this, how much you will get? 20, I think 1.023. And on solving this, you will get minus 0.79 as the answer. Where you made mistake in this?
Oh, I made mistaken like the signs only. मैंने उल्टा कर दिया.
Is I think तुमने 0.095 by 1 किया होगा.
Yeah.
Because you wrote the equation ulta. Aditi, any doubt here?
No, ma'am.
Shivani, for you also it is clear?
Yes, ma'am.
Okay, write down this one, then all of you do the next one. Next one is simple. First thing is you made the equation anode, cathode, and overall, and then put the values in the Nernst equation.
Mom, it's also E naught of Al3 plus by Al, right? Or is it E Al3 plus by Al?
E naught, no, it is E naught. E naught of Al3 plus 2Al.
I got the third one, I'm not sure.
What is the answer you got?
1.882.
Okay, we will solve it and check. This one randomly I have given a numeric. Now first we'll frame the equations. Pradhanya, you tell me the anode cathode equation.
Ma'am, AL is gonna be cathode, right? Because it's
Which one?
minus AL, right?
No, from cell representation only you can check na which one is anode, which one is
Oh,
cathode.
cell representation में AL will be anode.
So
So
what?
AL plus Ni2 plus is equal to AL.
No. Tell me the half cell only. Only anode
Oh.
equation. Al2. Al gives.
Mom, AL gives AL 3 plus and then 3 electrons plus 3 electrons.
Yeah. Tell me cathode equation.
Ma'am, Ni plus 2 electrons give Ni2 plus.
It's Ni2 plus 2 Ni. So Ni2 plus 2 electrons.
Plus 2 electrons give Na.
Now, when you add it, what will be the overall equation?
Oh, we should multiply it by 2 and 3, right?
Yes. So first equation with 2. So it should be 2Al plus 3
Ni2 plus is equal to 2 Al3 plus and 3 Ni.
Good. So this is the overall equation for this. Now we have to find the E cell. Uske liye first we find E node cell. Aditi, you tell me how to find E node cell.
Do we find it separately for Al and Ni?
E node cell is one thing, na? Because this is one cell. Here in the previous numerical, it was a single electrode, but here complete cell is given. So what is the E node cell formula?
E naught cathode minus E naught anode.
Now what is cathode here?
Nickel.
The value was minus 0.25 or what was the value given? Yeah, 25. And aluminium is minus 2.36. So we will get, I think, 2.11.
Yes, ma'am.
So that is the E node cell. Arjun, you tell me that. Okay, last time you only told. So will tell me. Shivani, you tell me the next step.
I mean, you have to calculate EMF. I mean, E naught of this cell, then minus, we use the equation, minus 0.0591 divided by N
What is and how many electrons you have cancelled in the final equation? In this equation, so what is the N value?
6.
The number of electrons you have cancelled in the final equation, it is N. So log of, what are the products here?
It will be Al.
3 plus and nickel, right? Nickel is a pure solid, so usko we can ignore.
Yeah, so Al3 plus divided by concentration of nickel, but yeah, it's solid, so 1.
अब इसका coefficient 2, it should be square. Divided by
nickel to the power 2.
to the power 3. Because your coefficient is 3. Now,
ma'am, Ni2 plus should be Ni, right?
no, products are Al3 plus and Ni. Nickel is pure solid, so we can ignore. So product is Al3 plus ka square. No, product me I am not writing nickel. Nickel should come here. And reactant kya hai? Al and this. Because Al is pure solid, so we can ignore nickel 2 plus ka cube. So 2.11 minus 0.0591 by 6 log. Vivan, you have done the same way? Got the same E naught value?
Just let me check.
For the same
Yes,
value
ma'am.
for the
Yes, ma'am.
10 raised to a minus, you did the squaring and
Yeah, ma'am.
cube.
Cube.
Hmm.
10 to the power minus 4 by 10 to the power minus 27.
Minus 9, na?
And it's cube, right?
Oh, yeah. Then it's a big number. 10 raised to a minus 3. Minus 9. 10 raised to a minus
Minus 9, it can't be
minus
27,
9.
it's 9.
Huh.
The
Because it,
whole comes as 10 raised to power 5. So log 10 power 5 is 5.
yeah, it's 10 raised to a minus 3 cube. So it becomes minus 9, not 27.
Won't 10 to the minus 3 whole square be 9 minus 9?
No, that
Oh,
becomes
yeah,
minus
yeah.
6.
Yes, ma'am. Got it. I messed up.
Mom, I did it a longer way.
इसका longer way क्या है? तुमने I think anode का you have
Individual.
हाँ individual करके
हाँ.
उनको subtract किया होगा.
Yeah.
नहीं, इसको इसी way से करो. It takes lot of time the way you are doing.
Mom, see, if it's a 5-marker question, more steps better, no?
नहीं, उसमें मिस्टेक, उसमें तुम राउंड ऑफ करोगे, मिस्टेक्स होने के चांसेस भी ज्यादा है एंड इट टेक्स लॉट ऑफ टाइम.
Fine.
6, it becomes log minus 4 by minus 9, it becomes 10 raised to the power 5 and log 10 raised to the power 5 is 5. Now you can solve it for this. 2.11 minus 0.059 by 6, you can take it as 0.01 because 0.059 is 0.06. 0.01 into 5.
2.06.
0.06 is coming. So answer is 2.06 volt. So like this you have to, and this question comes and always it is very simple thing. They will give you the same cell representation or directly equation they will give you. You have to substitute the values. Where the students generally make mistake, first point here. Always forget the square and cubing. They write concentration of products by reactants. If there is coefficient, mainly the students forget to do the square or cubing of the number. And second, how to solve the log thing. So you have to practice these questions. They will give you simple question in which you have to substitute the values in the formula. But you have to practice the calculation part. Tell me if you have a doubt in any step, I can explain it again. Any doubt here?
No, ma'am.
Okay,
No
now,
doubt, ma'am.
okay, now I'm explaining the next concept. It is related to Nernst equation only. I will restart my board. Write down calculation of equilibrium constant from Nernst equation. We will finish electrochemical cell today. Calculation of equilibrium constant from Nernst equation. Calculation of equilibrium constant from Nernst equation. Now, what is the equilibrium? You know that equilibrium is the stage when the rate of forward and backward reaction is same. So whenever the reaction is at equilibrium, and this is important point again for a MCQ question, whenever reaction is at equilibrium, E cell is always 0. For the reaction at equilibrium, E cell is always taken as 0. So if you write the, and what is equilibrium constant? If you remember last year you have done concentration of products by reactants at equilibrium is called equilibrium constant Kc. So at equilibrium, E cell is 0 and concentration of products by reactants is called equilibrium constant, which is Kc. If I am writing the Nernst equation, which is E is equal to E naught minus 0.0591 by N log concentration of products by reactants. So when we are taking the reaction at equilibrium, E cell becomes 0, not minus 0.0591 by N. Products by reactant is Kc. So what is the relation? E naught cell is equal to 0.0591 by N. N is same, number of electrons exchanged, log Kc. That is the relation between the standard electrode potential and equilibrium constant. Will give you simple numerical, either they will give you Kc value, you have to find E naught, or they will give you E naught value, you have to find Kc. So this point you should know, at equilibrium, the EMF of the cell is 0. Standard reduction potential will not change. It has a fixed value, E naught cathode minus E naught anode. But E cell is 0 at equilibrium. Last thing here in this, Gibbs free energy change. Delta G. You remember that also you have studied last year. Gibbs free energy change, how we can define it? It is the maximum amount of work that can be converted into useful work, that is known as Gibbs free energy change. The amount of work that can be converted into useful work, that thing is known as delta G. What was the application part of this? Delta G always measures the spontaneity of the reaction. Okay, if the value of delta G is negative, the reaction is spontaneous. If it is positive, reaction is non-spontaneous. If it is 0, the reaction is at equilibrium. So it measures the spontaneity of the reaction. So there is one relation between delta G and EMF of the cell. There is no derivation. Again, you remember the relation. NF E cell. Or delta G naught is equal to minus, if it is standard conditions, then it is E naught cell. Where is N? N here is same, number of electrons exchanged. F is called Faraday's constant. Which is 96,500 coulombs. Its value is fixed, 96,500 coulombs. What is that? That we will discuss in electrolytic cell. It is the charge on 1 mole of electrons. So that I will explain in electrolytic cell. Under normal condition, delta G is minus NF E cell. They will give you E cell, you find delta G. Or if it is standard Gibbs free energy change, then NF E naught cell. If value is given, it's fine. Otherwise, E naught cathode minus E naught anode, you can do. There is one more relation. There are two ways to relate delta G and Kc. There is one relation minus RT. I will convert log into natural log. 2.303 RT log Kc. Now there is one direct relation between delta G and equilibrium constant also. There are two ways. Either you can first calculate this thing, Kc, E naught cell from delta G naught, and then you substitute here, you will get Kc. Or this is the direct relation between delta G and Kc. Minus 2.303, R is gas constant. Its value is 8.314 joule per Kelvin per mole. T is temperature. Kc is equilibrium constant. We will practice one or two numerical based on that. This completes the one part of electrochemistry, which is electrochemical cell.
Ma'am, last class, did you do Daniel cell and all?
Yeah.
Okay.
That construction of Daniel cell and salt bridge vagara, that we have discussed. Now write down the question. Calculate equilibrium. I'm writing in short, equilibrium constant for the reaction. Cu plus 2 Ag plus gives Cu2 plus 2 Ag. It is given that E naught of copper is 0.34. E naught of silver is 0.80. Calculate Kc for this. E naught values of copper and silver are given. It is given that antilog of 0.6 is 3.98. Can tell me what should be the first step?
Oh, ma'am, electron potential of E cathode minus E anode.
E naught cell we will find, which is E naught cathode minus. So
Oh,
what
ma'am.
is cathode here?
Oh, ma'am, this thing. 0.8 Ag.
Minus 0.34. I think 46. 46 volt. Yeah. Aniket, what is the next step?
Yeah, ma'am, and then we use our formula, right?
Tell me the formula.
We use 0.46 minus
First
0.
tell me formula.
Okay, ma'am. So basically, I'm using like a different formula a little bit. So I'm using yeah. So I'm using like minus 0.0591 by NF. So it'll be 2 and 1 Faraday log Kc.
NF. Why you
Yeah.
want 0.0591 by N? Why are you
NF.
using F here?
Ma'am, because don't we
0.
have to,
When you are calculating 0.059, F उसमें include है.
oh, okay, it's include. Okay.
It's included. It's
Fine.
just
Okay,
N.
okay, yeah. Fine. And then log Kc.
So E naught cell is 0.46. What is N value for this question?
Will it be 2?
Sure or guessing it?
No, I'm saying.
It is 2. Copper is losing 2 electrons. Silver will gain 1, but there are 2 silver ions. So it gains 2 electrons. So 0.92 by 0.0591 is log Kc. So you will get the Kc value as antilog of this number. When you solve it, you will get as 15.6. All of you listen carefully this point. See, this value you are getting 15.6. But in question, it is given the antilog of only 0.6. So whatever number is given before decimal, that is always 10 raised to the power. It is 10 raised to the power 15. So what should be the antilog of 0.6? 3.98. So it should be 3.98 into 10 raised to power 15. And Kc has no units. 3.98 into 1015 is the answer. So whatever number is given before decimal, you just write it 10 raised to the power and then solve it. Now all of you do the next one. I'm giving you 3 numericals again. Do it. Fe2 plus 2I minus gives 2 Fe3 plus Fe3 plus 2 plus I2. E naught cell is given as 0.235 volt. Calculate Kc. Second है plus 2b plus gives A2 plus 2b. इसमें Kc is given as 10 raised to the power 4. Calculate E naught cell. Last is calculate the maximum work that can be obtained from Daniell cell. Calculate the maximum work can be obtained.
Ma'am?
Yes, Vivan, tell me.
So it should be 3 Fe2 plus, right, in the first question?
I will. It's given 2 only. I minus 2 I2. It's 2 only. 2 Fe3 plus to 2 Fe2 plus.
They won't be balanced now.
Balanced only. I minus 2 I2, 0, 1 into 2.
Okay, got it.
It's balanced. Now do these 3 questions fast.
For the first question, there's no log value given.
हाँ मैं वो देख के I will tell you which log I will show you. Just leave it as until whatever the answer comes, write down 10 raised to power that number. I will tell you what is the log value.
Ma'am, for the first one, we're supposed to take N as 6, right?
By how many electrons iron is gaining?
3.
3. Fe3 plus to Fe2 plus. How many electron it is gaining?
Oh, no, 1.
1. So there are 2 iron, it will be 2. And 2 I minus 2 I2, 2 electrons. So how many electrons it is exchanging
4.
here?
Okay, sorry.
Not 4, 2 only. Na? Number of electrons exchanged. Iron is losing 2, iodine is gaining 2.
Ah, okay.
So number of electrons exchanged are 2. You don't have to add it.
We calculate and like Fe3 plus is going to Fe2 plus. So it's gaining an electron, and because there are two of them, it's 2.
Yes. Fe3 plus 2, Fe2 plus 1 electron, I minus 2, I2 2. So balancing when we do, so Fe3 plus ko 2 se we have to multiply. So total electrons exchanged is 2 in the balanced equation. If you have a doubt in the first equation, I will write Fe3 plus, if you write the half cell equation, it should be like this. It will gain 1 electron and I minus 2, I2, because here there are 2 iodine atoms. It should be minus 1 to 0, but there are 2 here. So it will lose 2. So when you have to add the equations, first equation should be multiplied by 2. So the number of electrons which we are cancelling in the overall equation is 2. Here I will give you the antilog value. Antilog of 0.96 is 9.79.
Ma'am, can you explain again the first equation? Fe3 plus E minus. Why is it we're only adding E? Can you just explain it? I think.
See, in this Fe, you just check, don't see the stoichiometric coefficient. In this equation, Fe3 plus is converting into Fe2 plus. So how many electrons it will gain?
1.
1. So that is the first part. Now cathode.
Okay.
I minus is converting into I2.
That I understood. I didn't think that we should not just consider in the coefficients. I was considering coefficients.
So you have to multiply first equation by 2. So number of electrons exchanged will be 2. What is the first answer?
Ma'am, I got an answer but not matching with the anti-log, so I don't know it's correct.
What you are getting for the antilog thing?
I got the answer 7.83.
7.83. 7 point is correct. I think 83. Or what you are getting, Bhumika, what is your answer?
7.9.
7.9 is the 7.96 or 97 you will get. 0.0591. All of you just check. You have done N is 2 log Kc. E naught is 0.235 into 2 by 0.0591 log Kc. So when you solve it, you will get 7.96 log Kc.
Mom, I got 0.952 or something like that. So can I round it off to 96?
Yeah. Yes.
I took the value 0.06, so then I didn't.
That's why there is a small difference. It's fine. So Kc becomes antilog of this. This 7 ko you can write 10 raised to power 7 and 0.96 a value is given 9.79. So that will be the answer 9.8 into 10 raised to power 7. Now do the second one. Aditi, you have to explain me the second one.
So we can use the E naught cell is equal to 0.591 by an interlog Kc.
E naught cell is equal to
0.
0. By n log Kc. What is n value here?
2.
N is 2. And what is Kc value?
So we'll get anti-log 7.9.
But in this case, there is no anti-log, na? Because you have to find E naught cell. Kc is given.
Oh,
Why
ma'am,
you
the
want
next.
anti-log here?
Oh, I was looking at the previous one. Before this.
So it should be 0.0591 by 2. Log 10 raised to power 4 value is? What is the value for this?
4.
4. So it should be 2. So it comes out to be 2, 18, 11, 0.1182 volt. That is the second question. It was a simple, you have to substitute the values. Don't make mistakes in calculating n value. If you have a confusion in the overall equation, write the half cell equations and then you can check. Now come to the last question. Who will explain? Arjun, you explain with the last one. Calculate the maximum obtained from the cell. I think first one you only have explained. No, okay. Just tell me which thing you have to calculate in the third question. Maximum work that can be obtained from the Daniell cell.
Mom, I don't know how to do this.
Which thing you have to calculate? What is maximum work obtained from the cell? It is delta G, Gibbs free energy change. What is Gibbs free energy change? It is a maximum work, useful work, which can be obtained from the cell.
Mom,
So
so
indirect
minus NFP, nothing.
Yes, it is delta G naught minus NF E naught cell. What is N value in this case?
2.
2. What is F value? 96 by
9600.
What is E naught? You can calculate separately E naught cell. E naught cathode minus anode. What is cathode in this?
CU.
0.34 minus 0.76, so plus 0.76, which comes out to be 1.1 volt. So it is 1.1. So yeah, you have to solve. This value always comes out to be a big value, delta G. When you solve it, you will get minus 212,300.
I got it.
So same thing you got, joules.
Yes.
So it's always better whenever you are getting the value of delta G naught in joules, convert into kilojoules, because the chances of error in the calculation becomes less. When you convert into kilojoules, it becomes 212.3.
Ma'am,
Yes.
ma'am, we actually have to go out, so can I leave?
We are winding up. Yeah, we are winding up this last question. If you are done, then you can leave.
Yeah, I did the questions.
Then it's fine. You can.
Thank you, ma'am.
Yeah, bye. Now do this one. I check whether I have shared the worksheet, board questions of this. 1 second. Yeah, I have already shared the board questions. By next class, you have to do the electrochemistry, only Nernst equation ke numericals from that board questions. I have shared one document of board questions. So all the numericals of, I will tell you the question numbers. Just write down what is the homework. Question number 1, 2, 4, 7, 10, 12. All of you just note it down. This is the questions which you have to practice. 15, 16, 18, 20, I think that's it. 31. 31. So these all questions from the board question document you have to solve by the next class. If you have any doubts in this question, you mark it. We will discuss. But remaining all you have to do. And 21st ko you have a test of, I think, solutions chapter. All of you prepare it thoroughly. Solutions ka test. I will share it. No need to log in the class. I will share it. And within a time limit, you have to finish and send it to me.
What time will you send it?
I will send it in the evening around 4:30 or 4. So whenever you are getting time in the evening when you don't have a class, you write it. But write it honestly.
Yes, ma'am.
But write it in the same day. Don't extend it to weekend or something. Write it. I will just give you 1 hour test, not more than that.
It's on Friday.
Yeah, Friday.
Ma'am, Friday I have like another class to go to though.
And I have coaching on Friday.
What time?
4.
Yeah, for me it's like
Till what? Try to do the test on the same day. In case if you're not getting time, then Saturday morning first thing you have to do this and send it to me by 9 o'clock. Fine.
fine.
Aditi, for you it works?
I have school Saturday morning.
Saturday you have school?
Yeah.
Then do it before the school.
Okay.
Wake up early and then do it before school. Okay.
Yes.
So if you have no doubt, shall we wind up? Okay. Thank you.
Thank you, ma'am.
Ma'am.
Thank you, ma'am.